Okay, let's look at A. This integral is a simple, it's a log. This is a linear expression. The derivative is 3. So if we put u equal to the denominator, we'll convert this into 1 over u. And we're just missing the 3, so we'll have a 1/3 in front. So let's do that. Let's put u equal to 3x minus 2. So du is 3 dx, and 1/3 du is dx. So here we have 1/3. All right, so for dx, we're putting 1/3 du, and here we have 1 over u. So this is a simple log. All right, and then just substitute for u, substitute 3x minus 2, and you're done. All right, let's look at b over here. Okay, here's a definite integral. All right, this is 1. Let me write the 1 over x in the numerator. 1 over x, and then ln x. I just rearranged that integrand. So this is of the form the derivative of the denominator is right here, exactly in the numerator. So this is going to be a log also. If you put u equal to the denominator, log x. All right, then there's du, 1 over x, dx. All right, let's do the substitution. I'm going to drop those limits when I substitute and when I write the integral in terms of u. All right, so this is ln u. And that's ln of ln x. Let me just erase that plus c, because this is a definite integral. We have limits, so let me erase that plus c. Okay. And now that I rewrote the result in terms of x, we could put back those x limits, the x limits e squared, and start the substitution. So here we have ln of ln e squared minus ln of ln e. Okay, so ln e squared is 2. So there we have ln 2. And ln e is 1, so that's ln 2 minus ln 1. And ln 1 is 0, so this is just equal to ln 2. That's the answer. Okay. All right, and we'll look at C. All right, I'll go to another screen to look at C. Okay, we have a clean board now, so let me write down C. So this is the integral x squared and 3 minus x cubed dx. And this is of the form derivative of the denominator is in the numerator. The derivative of the denominator is minus 3x squared, and here we have the x squared without the minus 3. Okay, so we can just divide by minus 3. I'm going to do this one without a u substitution and take the log of the denominator. If you want to do the u substitution, you would put u equal to the entire denominator, 3 minus x 3 minus x cubed, like that. Okay, let's continue with 7D and E. Okay, now 7D is another log integral. If you look at the derivative of the denominator is 2x plus 6. 2x plus 6, notice, is 2 times 2x plus 3. So the derivative of the denominator is in the numerator except for the constant 2. All right, so instead of 2x plus 6, we have x plus 3. All right, so we're just missing the factor of 2 in front. All right, so for d, again, it's a log. It's the log of the denominator. And we'll multiply by 1/2 because we're missing that constant of 1/2 in the numerator. And again, you could do this by putting u equal to the denominator, and then you would get that constant of 1/2 would come out. Okay. All right, and the second integral is not of that type. I'm going to separate it. So here we have an inner function log x, and we have the derivative of the inner function is sitting on the outside. All right, so if we put u equal to the inner function, there's du is right there. All right, so maybe we'll do this one with a u substitution. Okay, so we put u equal to ln x, and du is right there, 1 over x dx. Okay, so this is equal to u squared du. And a simple power rule. Okay, so that in terms of x, that's ln x cubed over 3 plus c. Okay, let's look at these last two integrals. Okay, well, let's rewrite f. And if you realize that the derivative of x to the 1/3 is x to the minus 2/3, and we have 1 over x to the 2/3 right here, which is the derivative of x to the 1/3. So if we rewrite this with the derivative on top, x to the minus 2/3 then we have an integral of the form derivative of the denominator is in the numerator. Okay, the derivative of x to the of 1 plus x to the 1/3 is 1/3 x to the 1/3 minus 3/3, which is x to the minus 2/3. So we're just missing a constant of 1/3 over here. All right. Okay, so we can do this. Let's say we do this one with a u substitution. Put u equal to the entire denominator. Du is 1/3 x to the minus 2/3 and dx. Okay, so dx times x to the minus 2/3, which is what we have in the integral, is equal to 3 du. So we'll substitute for x to the minus 2/3 dx. We'll substitute 3 du. Let's put the 3 here. And we can put the du here. And u in the denominator. And that's just an ordinary log. Okay, so that's 3 log 1 plus x to the 1/3 plus c. All right, so let's go on to g. Well, g has the derivative of an inner function sitting on the outside. The derivative of 3x squared is 6x, so we have that here without the 6. Okay, so let's do our substitution. Let's do let's say u equal to 3x squared. Okay, so du 6x dx, and then solve for what we have. We have an x dx in the integral, so that's 1/6 du. Okay, so now we're ready to start substituting. Okay, so for x dx, we're going to put 1/6 du. Okay, that was for x dx. And here we have 5 to the u. And remember our formula for integrating a to the u. All right, that would be 1 over ln a, in this case 1 over ln 5, times 5 to the u. And finally, just substitute back. I'll let you do this part. Just substitute back u equal to 3x squared. And we're done. Okay, now we want to simply find some derivatives. All right. Okay, so we're going on to trig functions. We'll start with a, b, and c in number 8. Okay, so we know the derivative of sine is cosine, so we just have a simple chain rule here. Y prime is cosine 5x squared plus 2 times the derivative of 5x squared plus 2, which is 10x. Okay, the derivative of secant x is secant x tangent x. All right, so here we have y prime is secant 10x cubed tangent 10x cubed times the derivative of the inner function, and that would be 30x squared. And for c, we have the product of two functions, so we'll do a product rule. Y prime is equal to the first, x squared, times the derivative of the second, derivative of tangent is secant squared x, plus the derivative of x squared times the second function. Okay, we're up to number 8. 8 D and E. Okay. All right, let me just write that over here, number 8, in case you can't see that. This is number 8. 8 D and E. Okay, so we're just, for number 8, we're just differentiating. Okay, so let's do that. So first D. The derivative of cosecant x is minus cosecant cotangent. So here we have a minus in front, so that's just going to be cosecant x cotangent x. And the derivative of sine x is cosine x. All right, now here we have an arc sine, and the derivative of arc sine of an expression is 1 over that expression, or we put the expression in the denominator under a square root, 1 minus whatever that expression is squared. All right, so in here we have the expression 5x plus 3. And now just do the chain rule, and we're going to multiply by the derivative of 5x squared plus 3, so that's 10x. Okay, so 10x in the numerator.